Hey there, this is Chapter 11, Lesson 1, and today we are talking about mean. Our learning objective is I can calculate the mean and use the formula for mean to calculate missing data. So those are the two things that we'll do here. This will be calculating the mean, and then this little example is really important because that's how you that is how you do this part. Use the formula for mean to calculate missing data. So let's look at the real world link about music. Tina and her friends downloaded songs for 6 weeks, as shown on this table below. So each week they downloaded this many songs. How many total songs were downloaded? So I'm going to get my calculator ready. If you add all of these up, 12 plus 6 plus 10 plus 9 plus 4 plus 1, then you can get how many total songs? All right, so that would be 42 songs. So on average, how many songs did they download each week? So I'm looking for this word average here. And to find the average, you have the total songs, which was 42, divided by how many weeks there were, which was 6 weeks. And 42 divided by 6, we know is 7, because 6 times 7 equals 42. So on average, they were able to download about 7 songs per week. On the number line below, draw an arrow that points to the average. So 7 is the average. Plot the number of songs downloaded on the number line. So let's plot 12. You got 12 right here. And then 6, 10, 9, 4, and 1. How far below the average is 1, 4, and 6? How far above the average is 9, 10, and 12? So 6 is 1 below. 4 is 3 below. See that? 1, 2, 3. And then 1 is 4, 5, 6 below the average. 9 is 2 above. 10 is 3 above. 12 would be 5 above. So this would be how many below and how many above. What is the sum of the distances between the average and the points below the average or above the average? So what's the sum of the differences here? 1 plus 3 plus 6. So 6, 7, 8, 9, 10. That's the sum here. This is all 10. And then 2, 3, 4, 5 plus 5 would be 10. So the sum there would be 10. So they both have, a sum of 10 above or below the average. So why would the average be the balance point of the data? Look at this here. If this is the center, think of it like a balance beam, right? This data all averages out to 10 above, and this, well, not averages, but adds up to 10 below. So this is kind of like the in-between. So the average is like a balance point or a center of data. Now, another word for average is mean. So what we can say is average and mean mean the same thing, and you find them and calculate them the same way. So let's move on to calculating the mean. The mean of a data set is the sum of the data divided by the number of pieces of data. It is the balance point for the data set. So I'm going to say this is also known as average. It's a balance point. It's a center of data. On the previous page, you found a single number You found a single number to describe the number of songs downloaded each week. The average, or mean, summarizes the data using a single number. So the number that we found for the average or mean was 7. So this is all the data, and the average or the mean of the data is 7. That's kind of like a center point. You can find the mean of a set of data shown in different displays such as pictographs and dot plots. So, find the mean number of representatives for the 4 states shown in this pictograph. We have Tennessee, Kentucky, Virginia, and Louisiana. Now, instead of plugging it into add them all up and divide by how many there are, which is 4, this shows how you can move the figures to equally distribute the total number of representatives among the 4 states. So if we want to even it out to get a single number, like it talked about here, summarizing the data using a single number, you can, all right, I'm going to take one from here and put it down here because they don't have enough. So that one moved here. Take one from here. So down here and put it up there. And then take 2 from here and put them down here. And then you end up with each state evenly having 8 representatives. This right here we'll use in a minute, but I want to go off to the side here for a minute and let's see if we use our little formula if we would get 8. So Tennessee has 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6 for Kentucky. 6, 7, 8, 9, 10, 11 for Virginia. And 3, 6 for Louisiana. The sum of those divided, not divided by 6, divided by 4 should give us 8. 9 plus 6 plus 11 plus 6 is 32 divided by 4, which is 8. So this, if you have this little pictograph, you can move things around, or you can just add up the data and divide it by how many pieces of data you have. Now it says, do this problem to find out the mean. The table shows the number of CDs a group of friends bought. Find the mean number of CDs that the group bought. So if we were to do this little pictogram thing, then you'd have to say, okay, you have 3 here, 4 here, 6 here, 0 here, and 2 here. So now we need to read this. Even if a data value is 0, it still should be counted in the total number of pieces of data. So watch. If we need to balance this out, I could take these 3 and move them down here. So get rid of those, put them here. And I could get rid of this one and put it down here, and they all have 3. So I'm thinking the mean should be 3. Now, if we add all these up, 3 plus 4 plus 6 plus 0 plus 2, and we divide by there's 5 pieces of data, we should get 3. So let's check that here. 3 plus 4 plus 6 plus 0 plus 2 is 15. And 15 divided by 5 is 3. So 3 is the average or the mean. And what we'll do is we're going to move to using this method, finding the sum of the data, dividing by how many pieces of data there are. All right, here we go. Example 2. The dot plot shows the recorded high temperatures for 6 days in Little Rock, Arkansas. Find the mean temperatures. In a dot plot, individual data values are represented as dots above a number line. So we have 2 45s, 45 and 45, a 47, a 49, a 50, and a 52. So you find the sum of the data, add that all up. Adding those all up gives you 288. And then the number of data items, there were 1, 2, 3, 4, 5, 6. So 288 divided by 6 is 48. So the mean is 48 degrees. So all of the data values can be summarized with this single number of 48 as the mean. That's kind of like the center or the balancing point. If you draw that arrow again here, you can kind of see how that is a balancing point. All right, let's check this out. The dot plot shows the number of runs a baseball team had for each game of a 4-game series. Find the mean number of runs for the series. So let's do just like we did up here. Let's put all of our data to find the sum. So we had 1 plus 3 and then there were 2 4s. And the number of items is 1, 2, 3, 4. 4, 8, 9, 10, 11, 12. And then 4. 12 divided by 4 would be 3 because 3 times 4 is 12. So the mean number of runs would be 3, which would be right here. Cool. So here is our tip. Let's write this down. The easiest way to find mean is to, well, the first thing we did was get the sum of the data. 1, we had to add up all the data. And then 2, we divided by the number of pieces of data. So divide that sum by number of pieces of data. So let's see if we can do this one. The dot plot shows the number of books Deanna read each week of a month-long reading challenge. Find the mean number of books she read. So let's get this. Add up all the data. 1 plus, there are 3 3s here. 3, 3, 3, and then 2 4s. And we need to divide by the number of pieces of data. 1, 2, 3, 4, 5, 6. Okay, so that gives us 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 divided by 6. And 18 divided by 6, we know that is 3 because 3 times 6 is 18. Didn't even need the calculator. So the mean is 3. And look at how that would be like the balancing point there. All right, now the next page is the part that's a little bit tricky, and I don't like this because they don't give us a lot of room. But I need you to make sure that you show your work out with me because the way that we show our work is going to relate to how we solve equations. So this is the part right here that is this. Use the formula for mean to calculate missing data. All right. So let's just see here. The mean is sometimes described as the balancing point. Explain what this means using the data set. So the balancing point is where's kind of the center of data here. And actually, we might use this in a minute if we need more practice. All right, let's read example 4. The number of minutes Mary Ann spent talking on her cell phone each month for the past 5 months were 494, 502, 486, 690, and 478. Now, suppose the mean for 6 months, so this was only 5 months. What about if 6 months, the mean was 532 minutes? So how many minutes would she have talked the 6th month? All right, so see if you can picture this here. It says if the mean is 532, the sum of the 6 pieces of data must be 532 times 6, or 3,192. You can create a bar diagram. Okay, this is what I want us to do. This right here are all the 5 pieces of data, and the 6 month we don't know. So let's write that out like we would normally find, but let's use an X for the 6th month. So watch, 494 plus 502 plus 486 plus 690 plus 478 plus X divided by, well, how many months was it? 6. 1, 2, 3, 4, 5, 6. They're saying has a mean of 532. Now, let's simplify that. So if we add up all of these numbers, 494, 502, 486, 690, 2,478, we get this number here. Now I'm just double checking it's the same number they got, 2,650. So this simplified is 2,650 plus x divided by 6 is 532. Now how can we solve this for x? How can we solve this for x? First, oh my flying pencil. Okay, first, I'm going to split this down. Let's get rid of the divided by 6. How do we undo division? Multiplication. So if we multiply this side by 6, that will undo this 6. And what you do to one side, you have to do to the other. So now let's simplify it again. We would have this left over, 2,650 plus x equals whatever 532 times 6 is. 3,192. Now that's what they were talking about up here. 532 times 6 is 3,192. Okay, so now how do we get x by itself again? I want to have it just be x equals something. So I need to undo this. How do I undo addition? With subtraction. So I am going to subtract 2,650. That would leave us 0 plus x. So that gives us x by itself. So over here, I need to subtract 2,650. And when you take 3,192 and subtract 2,650, you get 542. So let's talk about what that is. And by the way, that's the same thing that they got. So if we were going to talk about what this number means, it means this number is our x. It's our 542. It's the number that goes here. So we should be able to add all of these up and divide by 6, and that gives us the mean, 532. So let's just check it. These all added together were 2,650 plus x we thought was 542, and that divided by 6 gives us 532, which is the mean they said we should get. So if you set up your equation for mean, giving x as the unknown data, then you can solve for x by first multiplying by what you're dividing by, and then subtracting both sides by the sum of the data that you know. All right, so that's what we're going to do. We're going to practice it, by the way. So hey, partner up. And we're going to practice it again here in number 2. So you have 1, 2, 3, 4 pieces of data. The 5th one you don't know. You're going to be dividing those by 5, just like here we divided by 6. And they give you the average or the mean. That's what you'll put on this side. So you're going to have a chance to practice it again down here. And if you need to watch the video with me, you can. So partner up for guided practice. All right, try number 1 and 2. Those are the guided practice problems today. Pause it and try this first one. The dot plot shows the number of beads sold. Find the mean number of beads. Go ahead and do that. Okay, so this is how I would do this. I would set up the sum, so that was this right here, add up all the data and divide that sum by the number of pieces of data. So we have 5, there are 3 7s and 2 8s. And there's a total of 1, 2, 3, 4, 5, 6 pieces of data. So 5 plus 7 3 times plus 2 8s is 42 over 6. 42 divided by 6 is 7. 6 times 7 is 42. So our mean is 7. Okay, so now you're going to try this one. If you need me to help set it up, you can watch me set it up, but then I want you to solve it. So it says the table shows the greatest depths of 4 of the 5 oceans in the world. If the average greatest depth is 8.094 kilometers, what's the greatest depth of the Southern Ocean? So here, if you want me to help you set it up with me, and then I want you to try to solve it. So I'm going to put these all out, and I'm going to call this X. 10.92, 9.22, 7.46, 5.63, and then there's X. And that would all be divided by 1, 2, 3, 4, 5. And that would equal this average, 8.094. Okay, now look at what we did up here. We got rid of the division part using multiplication on both sides. And then we got rid of the addition by subtracting from both sides to get X on its own. So that's what I'm going to do first. I'm going to get rid of this division by multiplying. Actually, you know what? I'm going to simplify this first. See how we did this? We added all these together to simplify it. That's what I'm going to do. So 10.92 plus 9.22 plus 7.46, 5.63. That gives me 33.23 plus X divided by 5 equals 8.094. Okay, now we can get rid of this 5. Multiply both sides by 5. So when you multiply both sides by 5, that leaves this on its own. I'm gonna have to rewrite it up here. I'm running out of room. So that leaves us 33.23 plus X equals, well, what's this times 5? 8.094 times 5 is 40.47. So now to solve this, just like up here, we subtracted the side with X to get X by itself. So we want X by itself. So we are going to subtract 33.23 from both sides. So, well, I guess you could just do it here. 7654, 2, the decimal. 40 take away 33 would be 7. So this should be the depth. Now you can check it. Let's try plugging it in for the depth. So all of these added together were 33.23 plus 7.24. And then when you divide it by the 5 oceans, it should give you this average is 8.094. So it works. So 7.24 kilometers is the Southern Ocean. Wow. All right. So now the thing I don't like about this chapter is it doesn't have like a ton of practices for each thing. So we're going to get some more practice in independent here. For the independent practice, we are going to do just 1, 2, and 3. That's it. So on 1 and 2, you're just finding the mean, just like we did here. And on number 3, you have to find a missing set of data. So you have all of these, how much she earned babysitting for 8 jobs. But what about the 9th time? What did she earn that time if the mean is 24? Okay, so solve 1, 2, and 3 and then check your answers. So checking our answers here, we took each set of data, added it up, found the sum, divided by 5 because there were 5 pieces of data. So 440 divided by 5 was 88. Here we took all of these pieces of data right here, added them up, which was 84, and divided by 6 because there were 6 pieces of data. 84 divided by 6 is 14. Now here we had all of these 8 pieces of data plus x, that's the 9th one that we need to find out, divided by 9 because there were 9 pieces of data. That equaled 24 was the mean. So I added all of these up. That was 191 plus the x divided by 9 equals 24. So to get rid of this divide by 9, I multiplied both sides by 9. 24 times 9 is 216. We are left with 191 plus x equals 216. So to get x on its own, you subtract 191 from each side. So x equals 25. And if you plug in 25 here, and add all these up, plus 25 divided by 9, you get 24. So now it's time for the reflection. All right, so your reflection for learning objective A is you'll be calculating mean and calculating missing data. First, explain in words how to calculate the mean of a set of data. Then use these 5 different costs of summer camp. 5 different summer camps cost 1, 2, 3. There are only 4. So we need to change this to 4 different summer camps cost this much. So what is the mean? And you can show your work down here, setting it up just like we did here. Use a calculator if you want. And then the points scored per game for 7 games. Let me make sure I got this one right. 1, 2, 3, 4, 5, 6, 7. There are the points scored. But what if there were 8 games and the mean was 90? How many points would have been scored during the 8th game? So I want you to show your work by setting up the equation and showing how to solve it, just like we did here. Set up the equation, simplify it, and then show how to multiply and then subtract from each side to solve for x. Okay, use your book as you need.